Assalamu alaikum warahmatullahi wabarakatuh. Good morning, children. So yesterday I taught you force on a current carrying conductor. Based on that formula, force on a current carrying conductor. Today we will do three numericals. Okay. So what is the force on a current carrying conductor? We got the formula. Just to easily to remember the force on a current carrying conductor. Force on a magnetic charge. So all these formulas we have seen. Magnetic force. Force on a moving charge, whatever it may be, force on a moving charge or magnetic force is actually F equal to BQB sin theta. F is equals to BQB sin theta, magnetic force or force on a moving charge. This derivation also we did. Now, yesterday class, I taught you force on a current carrying conductor. Suppose a conductor is there, current I is carrying. So, what will be the force on a current carrying conductor? To remember easily, F is equal to, just to remember very easily, F equal to Bill sin theta, you can remember. So, BIL, Bill sin theta. But always remember that. So, how you have to write in vector form, L cross B, that you should not forget. Okay. So, I L cross B, length of the conductor and magnetic field, L cross B sin theta or IL. Okay, L cross B. This is the vector form. L cross B sin theta, will remove that. So if you write the vector form, we should not use sin or cos. Okay. So F equal to I L cross B. So very easily to remember that F equal to Bill sin theta, like that you can remember easily. So force on a current carrying conductor formula is F equal to IL cross B or ILB sin theta or Bill sin theta, whatever the way you need, that way you can remember. Okay. Now based on this formula, we will be doing three numericals today. Now take down the numerical. So if I keep a dot here, if I keep a dot here, you know that magnetic field lines are coming outside. So magnetic field line or comes outside. This you okay. So here I am taking a square element. Current going so B, C, D. So ABCD is a square element. Length is given. Square of the length is at one side. The square of the length is 20 centimeters is given. Magnetic field lines are coming outside, and this the square frame is there. Current is moving. How much current is moving means 2 ampere current is moving. 2 ampere current is moving. So when a 2 ampere current is moving, this is a square frame. The length is given 20 centimeter. They are asking you find the force in each arm. Find the force in each arm separately. So AB, what is the force it experiences? BC, CD, and AD, and direction. So find the force in each arm force in each arm and direction. In the question. Okay. So find the magnitude and direction of the magnetic forces on the four sides of the frame. Four sides of the frame. So you know one concept. In current electricity we did, if your current is flowing, if your current, suppose here see 2 ampere current is flowing, this 2 ampere current, it comes and stops at this junction. So you know pretty well. So this current gets divided. This current gets divided here as well as here. Uniformly it gets divided. So here 1 ampere current flows, and here in this arm AB 1 ampere current flows. This 1 ampere current flows in series. So 1 ampere, 1 ampere. When it comes and stops here, here also 1 ampere, 1 ampere comes. So So here also in this branch 1 ampere flows, and in this branch 1 ampere flows. Both 1 plus 1 added together, again 2 ampere comes out from the. Okay. Now the question is, find the force in each sides. So AB, what is the force? BC, what is the force? CD, AD. So how we will find out? We know that force on a current carrying conductor formula, F equal to, I told you very clearly, I L cross B or ILB sin theta. So force we know force on the carrying conductor is equal to I L cross B, or you can get F equal to ELB sin theta. So by symmetry, the current 2 ampere gets divided. So 1 ampere will flow. So here 1 ampere current flows, and here in this side 1 ampere current flows. Okay. So from the junction, here is the junction. So 1 ampere current flows this side, 1 ampere current flows that side. The total output is 2 ampere. In is 2 ampere, out is 2 ampere. Now, bacho, first we will talk about the AB. One side, if you talk about the one side. So F equal to what is the current is going? Current is 1 ampere is going. Length of the conductor is 20 centimeter. Magnetic field, sorry, if I forget to give you magnetic field. Magnetic field is given 0.25 Tesla. Okay. The magnetic field is given as 0.25 Tesla. So sine theta, what is sine theta? Length of the conductor with the magnetic field. So length of the conductor with the magnetic field, angle between length of the conductor and magnetic field. Magnetic field direction you see outside. Magnetic field dots, if I keep dots, magnetic fields are coming outside. Now current you see, current is going downward AB. So magnetic field is in this direction, and current is, or you can keep the left hand rule. The force and a current carrying under left hand rule you can use. Magnetic field goes towards you outside, okay, like this. And then what about the current? Current is going downside. Current is going downside. Okay. That means, or if you keep in your paper, you are writing, you are writing in the paper. This question you are writing in the paper only. So you see that when you write in the paper, you put the dots. So when you put the dots, magnetic field lines are coming outside the paper. The magnetic field lines are coming outside the paper. So because you are writing in the paper only, A4 paper, you are writing the exam. So you can think that magnetic field comes outside the paper, outside the paper. Then if you see that the current is going in this direction, the magnetic field lines are going outside, and current is going in this direction. So here to be in this direction. That means, see, magnetic field lines are going outside, and the current is going in this direction, current direction, and the force existing left side. The force will be existing and left. Yeah. The same thing will happen here also, because the current direction here and here it is same. See, the current direction A to B and B to D, D to C is same. So force will experience a left side in AB and DC. In AB and DC, current will go left side. In the same way, if you see, you are writing in the paper, again you see, take care of, you are writing in this diagram you are doing in the paper. So dot if I put means outside the paper it comes. So you keep your finger like this, outside the paper it comes. And then you see that current for this AD conductor, we talk about the AD conductor. So current is going outside, and then current is going A to D. So this side. So this is the magnetic field direction outside the paper. And then this is the current direction. This is the current direction. Now you see that then this will be, so if this is the magnetic field direction, and this is the current direction, and this will be the force on a conductor. So force will be like this. That is downside will come. So just take care of your paper and keep your paper in your paper. Apply the Fleming's left hand rule. Apply Fleming's left hand rule. Fleming's left. Those who forget left hand rule, right hand rule, I'll explain you. Intentionally, you studied Fleming's left hand rule and Fleming's right hand rule. So whatever be the left hand rule and right hand rule, we use first three fingers. And I have the first three fingers. The first finger is the middle finger, index finger, then middle finger, and then thumb. We take three fingers. Mutually, we keep perpendicular to each other. It should be perpendicular to each other. If the thumb finger, this is the thumb finger, this is the this is the index finger. If the index finger, clearly please note down, if the index finger represents the magnetic field direction, then the middle finger represents the current direction, then automatically the thumb finger represents the force. So please remember that this is the middle finger, middle index finger, and this is the middle finger, this is the thumb. So index finger magnetic field, and this is the current direction, and this will be the force. In the same way, if you take stretch the left hand rule, same thing only here also. This is the index finger, middle finger, and then thumb finger. So index finger represents the magnetic field direction, and then this middle finger represents the current direction, then the thumb finger represents the force. So this you should not forget. So that's what I used to give in the previous notes. So please remember that again for your reference I'm giving you here, whether it is a left hand rule or a right hand rule. Please note down this, whether it is a Fleming's left hand rule, Fleming's left hand rule or right hand rule. The first one is the index finger, middle finger, and then thumb. Okay. So in both sides, if you see, everything is same only. So index finger always represents the magnetic field direction. Magnetic field direction, B vector. B represents B vector. And then the middle finger always represents the current direction. Current direction. And then thumb represents the force. Thumb represents the force. Okay. So, sir, you can ask me, sir, left hand rule also same thing saying, and right hand rule also same thing saying. Yes, of course. So we use this left hand rule. That's why we use this as a motor rule. Instead of this left hand rule, one more word is there. We use in the motor, the coil rotation, motor rule. And here we can say a generator rule. Generator rule. In both the things, if you see, input and output is different. Here output is current. Here output is the force. That also you should remember. So here in motor rule or Fleming's left hand rule, the output is current. So here, sorry, output is force. Output is force. Here output is the force. So here in right hand rule, the output in generator rule, right hand rule you can say, or you can say generator rule. So here the output is current. Okay. So when you use these two as input, and this will be the output. When you use these two as input, and this will be the output. Okay, but so this intention itself we studied. So the same Fleming's left hand rule we are using here, force on a current carrying conductor. Okay. Hope you understand. So now come to the numerical. So F equal to ILB sin theta. So just you will for one some symmetrical diagram. So one conductor, if you find that is the same force, same value, same magnitude will come for all the four conductors. Only thing is the direction changes. Okay. So F equal to current in one conductor AB, FAB. The current, how much current is flowing? 1 ampere. Length is 20 centimeter. Why we write 10 power minus 2? We convert centimeter into meter. Magnetic field 0.25 Tesla. Our sign 90. Magnetic field and current direction. And magnetic field comes like this. Our current goes like this. Therefore, दोनों perpendicular होता है 90 degree. So sin 90 is 1. Okay, बच्चों. So if you calculate that F equal to 20 into this also you can write 25 into 10 power minus 2 यहाँ पे minus 2 है और इसका भी 25 का भी minus 2 आएगा Sin 90 is what? So 25 into 2, 500. So F equal to, is it visible? Yeah. F is equals to 500 10 to the power minus 4 is equal to 510 to the power minus 4 Newton. So the answer is 0.05 Newton or 0.05 Newton. So please listen very carefully. Once again, I'm telling you. So this is a coil, square coil is given. Inside the magnetic field is given. How the magnetic field comes? Magnetic field comes outside the paper. Okay, you are writing the paper. So outside dot is there now. So magnetic field comes outside the paper. And there are four arms is there. A to B, B to C, or C to D. Okay. A, B, C, D is a square frame. Each side is 20 centimeter. 2 ampere current is flowing. Magnetic field is 0.25 Tesla. Now they are asking you, find out the magnitude and direction of the force in each arm. Okay. So force of a current carrying conductor formula you should know. Bill sin theta. So how we will write vector form? F equal to I in L cross B. L cross B or F equal to ILB sin theta. So this sin theta angle between the L length of the conductor and magnetic field. Length of the conductor and magnetic field. In दोनों का angle. That is 90 degrees. Now you know symmetrical diagram. So when 2 ampere current flows, it comes and stops at the junction and it gets equally divided. है ना बेटा? So 1 ampere current flows in this arm, 1 ampere current flows in this arm. They join together at the C point, then 2 ampere flows. So now you substitute in the formula F equal to I. I is 1 ampere and length of the conductor is 20 centimeter. Our magnetic field is 25, 0.25 Tesla. So when you substitute all the things, you get the answer is F equal to 0.05 Newton. So everywhere, all the four arms, same value only will get because of the symmetrical current. F equal to 0.05 Newton is the force is the answer. So in every arm, you get the same answer, but the direction of the force is changed. Okay. Next question. Shall we go to the next question? Please copy this. Now we go to the second question. Triangle is given, equilateral triangle is given. Okay. Equilateral triangle is given. PQR. Magnetic field given. That means magnetic field is parallel to PQ. Magnetic field is given parallel to PQ. Then, so given equilateral triangle, equilateral point two, forces acting on the forces acting on three wires. So equilateral triangle is given bachcho PQR. I current is flowing. Okay, PQR. Magnetic field, they have given a condition. Magnetic field is parallel to PQ. That means magnetic field is going in this direction. That is parallel to PQ vector. Okay. Now find the forces acting on the three wires separately. So this is one wire PQ, QR is one wire, RP is another wire. What is the force is acting in each wire separately? Find it. So please copy the numerical. Now, what is sine 0? You know that sine 0 is 0. है ना बेटा sin 0 का वैल्यू 0 होता है. Sin 90 is 1. Sin 90 is 1. Sin 0 means theta equal to 0 degree. Sin 90 means theta equal to 90 degree. That means L cross B. Length of the conductor and magnetic field, if it is perpendicular, you should use 90. Length of the conductor and magnetic field, same parallel means then theta equal to 0 degree. Okay. So we know force on a current carrying conductor. Force on a current carrying conductor formula you should know. Force on a current carrying equal to I LB sin P. So first we will calculate PQ conductor. So force on PQ. Force on PQ. So what is the current? Current is I only is given. Length of the conductor. Same length only I hope so. Equal to L. Yes. Side is L. All side is L. Okay. Equal length is given. So I length is L only. Magnetic field. Yes. Magnetic field B only is given. What is sine theta? Here you carefully watch that. PQ and magnetic field, they are all the magnetic fields goes like this now. So magnetic field is parallel to PQ. That is sine 0 degree. Therefore, sine 0 means 0. So you completely force on PQ will be equal to 0. Force on PQ will be equal to 0. Force on QR. Force on Q. The same formula, ILB sin theta. Force on QR will be equal to I is I, L is L, B is B, sine. Very carefully watch here. So magnetic field is here. Magnetic field is completely going in this direction. So this will we are talking about the QR conductor, and magnetic field is going in this direction. So listen, this is the magnetic field direction. Okay, magnetic field, and this is the conductor. This is the length of the conductor, and this is the magnetic field. You know, beta? So now I told you L cross B. L cross B means this angle we want. So this angle. So this is the length of the conductor. Very carefully watch here. This is the length of the conductor because we are talking about the QR conductor. What is the force on QR? So QR is going in this direction. Length of the conductor, this one, and magnetic field is going in this direction. So L cross B means this angle you should calculate. So if it is a straight line means this is 180 degree. Equilateral triangle means that also 60 degree. So 180 minus 60 will be equal to 120 degree. So this is not given in the diagram. So you should know that. So sine of 180 minus this equilateral triangle, this angle you minus this. So 180 minus 60 will be equal to 120 degree. That is sine 120 degree. Okay. So F QR will be equal to I L B sine 120. So the answer is F equal to ELB. What is sine 120? Sine 120 is root 3 by 2. So F equal to ILB sine 120 is root 3 by 2. Okay. Now in the same way, you try, pause the video and you try for RP conductor. Okay. Yeah. Hope you have done the answer. So now, yes, the conductor will be equal to ILB sin theta. The length of the conductor is this, and again magnetic field is going like this. So this angle, same thing. Here 120 means this also 120. So same answer you get. Therefore, RP will be equal to I is I, L is L, B is B only it is given. So sin 120. So the answer is FRP will be equal to IL3 root 3. Okay, please copy. Over. Now one more numerical we'll see force on a current carrying conductor. Magnetic field is given like this. Third question, magnetic field lines are given like this. So there is a 3 wire they are given like this. A current is flowing. This is 30 centimeter and this is 120. Again, I current is flowing. Okay. PQ, P and P and okay, बच्चों. Find the magnitude of the magnetic force segment. Segment PQ. Find the magnitude of the magnetic force on the segment PQ if a current of 5 ampere flows. If a current of 5 ampere flows with the magnetic field 0.2 Tesla, 0.25 Tesla. Okay, bachcho. So how to do this? Same formula we have to use. So see this magnetic field direction is given like this. So this arrow marks tells you the magnetic field direction. Magnetic field direction full of magnetic fields goes like this. Okay, magnetic fields are going like this. Now, when the magnetic field goes, then in this conductor I it is parallel. Magnetic field and the current is parallel. So theta equal to 0 degree, F equal to 0 degree, sine 0. Here also in this conductor also sine 0, it is 0. Force is 0. But here it is not 0. You know, but the PQ is making some angle with the magnetic field. So what is the angle? So we know the formula force, the formula I L cross B sin theta. Sorry, I L cross B cross डाले तो sin theta यूज करना है. I L B sin theta बोल. F equal to I L cross B. This is in vector form. So F equal to I L B sin theta in a normal form. Cross product we use sin. Okay. So F equal to segment. Which segment they are asking? PQ segment. So force on the PQ segment. What is the force on the PQ segment? So force on PQ segment equal to same numerical. What is current? Current is given 5 ampere. What is the length of the PQ? 30 centimeter. 30 into 10 power minus 2. What is the magnetic field is existing? 0.25 Tesla. So 0.25 Tesla को easy conversion के लिए 25 into 10 power minus 2 लिख लीजिए. 25 into 10 power minus 2. Okay. So I is over, L is over, length is 30, magnetic field is 0.25 Tesla. Sin theta, this is very important. Sin theta, theta represents the angle between L, length of the conductor, and magnetic field I told you. So this is the length of the conductor and magnetic field is going in this direction. So ऐसा जा रहा है ना magnetic field. So length of the conductor and magnetic field angle is not 120 degree here. Length of the conductor and magnetic field is, this is 60 degree because total straight line is 180. 180 minus 120 is 60 degree. 180 minus 120 degree is 60 degree. So here sine is 60 degree. Therefore, into sine 60 degree. So if you calculate this, F P Q will be equal to, so please try yourself, 5, 30 into 10 power minus 2, 25 10 power minus 2, sin 60 का वैल्यू डाल लीजिए. So F का आंसर is given 0.32 Newton. This all of you check in with your calculation whether it is correct. So force is given 0.32 Newton. Okay, बच्चों. So we are studying this fourth chapter. We are going to finish. Two more topic is there, and force on a current carrying, parallel current carrying conductor is the next topic, and then last very important 5-mark question is moving coil galvanometer is there. So magnetic force, if they ask you magnetic force or force on a moving charge, F equal to BQV sin theta. Formula is as usual. Formula is very important. Please never forget the formula. Force on a moving charge, F equal to BQV sin theta. Force on a current carrying conductor, F equal to Bill sin theta. So L cross B. So these two formulas, please remember very carefully. And based on that formulas, we have done few numericals also. Please practice well. We'll see you in next class. Next class topic is derive an expression for the force on a parallel current carrying conductor. I will see you in next class. See you. Bye. Take care.